So welcome back again, still on complex number. So having understood the complex number, so one thing you need to understand is you can add the real part and imaginary parts of complex numbers. For example, if z is equal to 5 plus 7i, that's z1, and z2 is equal to 4 minus 2i, so you can find z1 plus z2. Okay, then when you're adding two complex number, what you are going to do is to add the real part and also add the imaginary part. It's as simple as that. So that becomes 5 plus 4 plus 7i minus 2i, and this is 9 plus 7 minus 2 is 5, then I, isn't it? So that is the solution. I believe this is well understood. Then also you can multiply two complex numbers. For example, the same example z1 and z2, I can find z1 multiplied by z2. Okay, so when you want to do this, this will become 5 plus 7i multiplied by 4 minus 2i. Okay, 5 plus 7i here, over here. Let me print this and write it properly. 5 plus 7i. So it's just the normal way you multiply, normal way of multiplication. That becomes 5 times 4 is 20. Okay, 5 times minus 2i becomes minus 10i. 7 times 4, 7i times 4 becomes plus 28i. Then 7 times minus 2 is minus 14i. Okay, so 5 times 4 is 20, minus 10i plus 28i minus 14i. So then you add in, this should be 7 minus 14i squared, isn't it? Yeah, now that is not correct. Now don't forget this I squared, I is the square root of minus 1. That means I squared will be equal to the square root of minus 1 squared, isn't it? That becomes minus 1. That means I cube will be equal to the square root of minus 1 cube, isn't it? Which will be equal to the square root of minus 1 times square root of minus 1 squared, of course. Square root of minus 1 squared is minus 1. That becomes minus I, isn't it? Because square root of minus 1 is I. So don't forget this whenever you are doing your expression. Always check when you have I to more than the power of 1. So that implies that this becomes 20 minus 10 plus 28 is minus 18i, and this is minus 14. Then I square is minus 1, isn't it? Like I've showed you here, the value of I square is equal to minus 1. So this becomes 20 minus 18i plus 14. So 20 plus 14 is 34 minus 18i. I hope this is well understood. So that is multiplication of two complex numbers. So we've done addition of two complex numbers and multiplication of two complex numbers. Now for division. Now, to divide, before you divide, one thing you must first know and understand is called conjugate sorts. Conjugate complex numbers. That is the first thing you need to understand before you divide, because you cannot just divide complex numbers. You can also call them complex conjugates. Complex conjugates. What does that mean? When you have z is equal to x plus iy, its complex conjugate is equal to x minus iy. So you must understand these two things before you divide. So let's take an example for division. An example: find the real and imaginary part of 1 over 5 plus 2. Whenever you are dealing with division of complex numbers, you must introduce the concept of conjugates. So what are you going to do to this? You are going to multiply both the numerator and the denominator by the complex conjugate of the denominator. What does that mean? 5 plus 2i its complex conjugate is 5 minus 2i. So that becomes 1 over 5 plus 2i multiplied by 5 minus 2i divided by 5 minus 2i. So you must multiply both the numerator and denominator by the complex conjugate of the denominator. I hope you understand that. So why? Because when you multiply two conjugates, you will get a real value. Then that real value makes the division of complex number easy for you to work with. Okay. And if you take a look at this, if you cancel out these two guys, you still get your original expression. So at this point, this becomes 5 minus 2i divided by, then 5 multiplied by 5 is what? Is 25. 5 multiplied by 2i is minus 10i. This is plus 10i. And this is minus 4i squared. I hope this is understood. This becomes 5 minus 2i divided by 25 minus 10i plus 10i, of course, cancels out. I squared is negative 1. Then this becomes positive 4, right? So this becomes 5 minus 2i. 25 plus 4 is 29. I hope this is well understood. So but the question is not yet completed. It says find the real and imaginary part. So to find the real and imaginary parts, so you are going to break down this into two fractions from one fraction, so that this becomes 5 over 29 minus 2 over 29i. So which means this is the real part, okay, and this is the imaginary part. So that means the real part is 5 divided by 29, and the imaginary part is equal to minus 2 over 29. I hope this is well understood. So here is another example. Like I told you, whenever you are dealing with division of complex numbers, always introduce the concept of complex conjugates. So this is 9 minus 4i divided by 2 plus 3i. Like I said earlier, you multiply the numerator and denominator by the complex conjugate of the denominator. So that this becomes 9 minus 4i over 2 plus 3i multiplied by 2 minus 3i over 2 minus 3i. Okay, so this becomes, of course, 9 multiplied by 2 is 18. 9 multiplied by this becomes minus 27i, and this becomes minus 8i, then plus 12i squared, isn't it? Divided by 2 times 2 is 4, minus 6i plus 6i minus 9i squared. Okay, so this becomes 18 minus 27 minus 8 becomes minus 35i minus 35i. Then I square is negative, then this becomes is negative 1, this becomes minus 12. Of course, this cancels out, isn't it? I squared, like I said, is negative, then this becomes 4 plus 9. Okay, so 18 minus 12 is 6 minus 35i, and 4 plus 9 is 13. So you are asked to express this in the form of x plus iy. So the question is not completely solved there because it is not yet in the form of x plus iy. So to write it in the form of x plus iy, you have to break down this fraction into 2. So this becomes 6 over 13 minus 35 over 13i. So where 6 over 13 becomes x, and what? Y is minus 35 over 13. I hope this is well understood. It's as easy as ABC.